Hi guys, there is some disturbance right from outside. I don't know how I can stop that. Damn, we already have 7 viewers and a like. Hey guys, I wanna confirm to you people again. Don't don't skip your exams. I mean, if you have exam preparation, prefer that over these silly streams. Okay, can you guys hear me? We have grinding into Abyss, Prismax, Abhishek Sharma. I have seen those names before. I mean, Prismax is known. Grinding into Abyss also comes sometimes. I know that. So yeah, maybe ask me something, or we can just try starting solving some problems. Can you guys hear me well? Also like the video because you guys know it's gonna be better. Yeah, fine. So I will ask you one question. Okay, I will ask you guys one question. This question is about problem solving. Okay, do you guys think problem solving is getting some great idea or seeing the problem for what it is? I'm not in an hostel, it's a PG, I guess, but it's quite spacious. There is another room behind. I keep it dirty, but there is another room behind too. I keep it dirty, but yeah, there is another room behind. It's a two people shared PG, but it's quite spacious. Even the washroom is spacious. I'm a vlogger now. I guess I'll get more likes this way because people can't sit straight without seeing multiple things. Fucked up attention span, right? See, you people are also interested in home tour rather than the. Yeah, yeah. So my question: do you guys heard my question? I'll put the poll. Okay. Turn it to something beautiful. It's I should share my screen too, right? So, guys, like the video. We need more likes than viewers. As you guys know, people keep leaving, right? Yeah, be active. I'm making a poll for you people because I cannot interact with so many people, right? Bro, I have a suggestion. Post your streams on CF like high rated people have a feature to post. I know that. For that, I have to become a grandmaster. Prismax. Once I become a grandmaster, I will just post. I don't care, I guess. Or I will make a blog, like at least to attract Indian viewers. Mahendra Singh, what did he ask me though? Yeah, how to reach expert, bro? I am trying to give in general problem solving tips on everything, right? Because from expert to CM, if you see my streams, you will have a very good understanding because I'm solving much higher ratings too, right? I look shit. I look like shit somehow. I don't know what to do. Lighting or uh, learning topics is not an option. Learning topics is not an option. New stuff is not an option. There are no new topics, bro. You have been lied to. I'm just joking. Really, there are no new topics. If you guys try to prove things, you will learn more. That's it. You can learn everything on your own. Just try to prove small things because there are no weird things. I don't know any topics most of the time. I think really, if you prove things, you can learn more topics. Not topics. You can learn more concepts. not even asking the right questions. It's actually seeing the problem for what it is. It's actually seeing the problem for what it is, bro. BFS, DFS are not shitty. They are just some nice algorithms. Okay, they're not shitty. So you have to prove them to them. Like, see, there are some topics. Maybe try some book, right? Maybe try some algorithm related book. Maybe try reading some mathematics related book. Maybe try reading some graph related book. Maybe like it's not that difficult, right? To it's not like out of somewhere, right? You know that there are some graph traversal algorithms. Maybe read them somewhere, or before reading them, try to think on your own what all you can say about the algorithms or things like that. Okay, how to prove is like you have to, I am showing. Okay, so just give me some problem. Maybe like we have to, I will get to GM, bro. I don't know. I don't get. I don't. If there is a contest that happens every day, I would have been GM. I would have touched GM because I fuck up, I do good. I fuck up, I do good. So they happen randomly. So maybe now I'll see if I can become GM or not. I will be at least because I won't stop till then, right? So yeah. So guys, we have to keep the stream interesting too. So maybe give me a problem. Like proving things are not that difficult, Kailash Chowdhury. It's not that difficult. It's you just have to try. Proving means like it won't be like too complex. Like how you get the solution is almost proving only. Like using some logic you will prove. You will improve your logic. No bro, I graduated. It's been an year too. I have 1 year work experience too. So guys, give me a problem now. Is this audible now? Fuck off. Yeah. So I will talk maybe a little bit of shit till 10 minutes, but I need a problem until 10. So what should I do? Should I see my leak code profile? Maybe I will start sharing screen because you guys are not able to give me something. ABC, I understand, bro, but I'm not in a mood of solving ABC because last time I had an ABC, it was just an expected problem, right? Last time that I have tried. So should we solve? I'll just try to solve this problem, okay? I have good math knowledge, I guess. Like, not math knowledge. Like, it's not of much. It's not much of math knowledge. I don't solve much of lead code. Let's see if I have a profile in lead code. Your skin and bones, so yeah, your skin and turning to something beautiful. Don't see my emails. I'll close them with my hand. It's asking me to sign up. Mm. No, I can't show all these things here. Fuck all my emails to you random people now. Uh, 22 or so, but see, bro, try to learn from what you're getting from this stream, okay? Try to learn from whatever you get from this stream. So, we have gotten a problem. So, guys, what should we do? Let's solve some 2600. Okay, let's try to give our best. I know you people will drop because you guys are scared. Don't be scared. So let's just try some 26 or more. I don't know. Should we try some 26 to 29? Let's read whatever the random problem that comes. Okay. Guys, take a pen and a paper. Okay. Take a pen and a paper. I will teach you people problem solving. Okay. Problem solving is seeing the problem for what it is. Really, problem solving is seeing the problem for what it is. Even if it's a much difficult problem, in problem solving, what you learn is to see the problem for what it is. Really, that's what you learn. It's difficult. Even I try to do the same thing because it's that skill to being able to see the problem for what it is. Really. So if you guys don't believe me, let's try to take some problem. Okay. This one I have tried already. If I have tried a problem already, I'll get scared of that. Okay. So what should we try? Should we try this one? It's written fallen towers, it seems. Okay, let's try to read this problem once. Okay. And try to see what can we do. Let's try to read it. I mean, if I can solve this problem, I'll go to something else. But let's read the problem now. Like, let's read the problem and see what all we can do. Because why am I taking a difficult problem is then you guys can relate to me, right? It's the same all problems are same type of level, and not just you guys being related to me. Any problem is same. You can try to solve the same problem. See, you cannot solve it 1300, let's say. You cannot solve this problem too, so you have to try in the same way anyway. It doesn't matter to you, right? So let's try to solve this problem. We need viewers, because let's try to solve this problem. We need viewers. So let's try to solve this problem. Be there, all the 24 people right now. You may spend a lot of time, but then this would be more productive because it's something that you wouldn't do in general, right? So stay there. If possible, like the video. If you learn something, already dropping, people are so fucking scared. So yeah, let's try to see this. Pisano, I mean, if not this, we'll read another problem. And then if not that, we'll read another problem. We'll keep reading problems until we solve one, until we let's try to judge. See, if I say problem solving is, I have to write that somewhere. Problem solving is seeing the problem for what it is. That also says that you should be able to judge. Yeah, all of you, I prefer you guys take a pen and paper and try to follow whatever I say. Okay. So if problem solving is the problem for what it is, you should be able to judge the problem too from above. It's not like random try and then random idea and all. You should be able to judge the problem from a bit above too. That helps in contest. So if you can read a problem clearly, carefully, and then try to judge the problem, and then try to solve the problem, like trying to see the problem for what it is. So let's try to read the problem first. Pisano built an array of n towers, and let's see if this demands some topic. Okay, if this demands some topic or not. Let's try to see that too, because you guys said topics, right? Where do I learn new topics? So let's try to see this. uh, Pisano built an array of n towers, each consisting ai greater than or equals to 0 blocks. So we have n towers with some blocks, each of them. This is not complex, right? Pisano can knock down a tower so that I cannot probably solve this, but still, let's see. Pisano can knock down a tower so that the next AI towers grow by 1. So, so if you knock down this tower, the next AI towers grow by 1, it seems. In other words, you can take the element AI, increase the next AI elements by 1, and then set AI to 0. So what happens is this AI things will go, and then 1 1 1 1 1 will be placed in the next towers, it seems. Okay. The blocks that fall outside the array of the tower disappear. Okay. So far I don't see topics. So far I don't see any topics, right? Logic. We have to apply the logic. So everything in here is like a statement, right? Whatever they are saying is a statement. You have to get the solution using these things only. You cannot get the solution using some outside topic, right? You have to prove. There will be a simple proof if the solution is correct. So if Pisano knocks down a tower with 0 blocks, nothing happens. Yeah, that makes sense. Pisana wants to knock down all n towers in any order exactly once. So this is what he wanna do. He wanna knock down all tower exactly once. That's what he wanna do. That is, for each I from 1 to n, he will knock down the tower at position I exactly once. So like somehow he knocks them like a permutation, knocking down permutations. Moreover, the resulting array of the tower heights must be non-decreasing. So after all these knockings, the resulting array of the tower heights must be non-decreasing, it seems. So it should be increasing. This means that after knocking down all n towers for I less than j, the tower, okay, see, they are even explaining what non-decreasing is. What non-decreasing is: for all I less than j, for all pairs, tower I must not be taller than tower j. So if these people are explaining what is non-decreasing, do you think this question needs topics? You have to logically use, okay, what is non-decreasing, you have to logically use exactly once thing, we have to logically use whatever the operation is, and then you're required to output the maximum max of the resulting array of tower heights. So there is an operation. Let me so there is an operation for an index I. We should do this for all indices exactly once, and then final result should be non decreasing, and then we need maximum max of the resulting array. So there is a constraint. There is a constraint on the final result too. Because see, we cannot say if this constraint is not there, maybe the problem is unsolvable. If this constraint is not there, maybe the problem is unsolvable. We have to use these things logically, and then we have to find the answer. And if you believe in golden rules that solutions are simple, proofs are simple, implementations are simple, that means there is a simple solution to this problem, definitely. Because you can only use for loops, you can only use indices, you can only do some things in our code forces, right? In coding, you cannot do random weird things, right? There are no AI black boxes here. And you may probably find the, you have to prove to, because you will be able to prove to, you will be able to prove that, you must prove that if you are solving the problem, you must prove that this is the maximum max of the resulting array. You must prove that too. Okay. So, does this problem seem to involve topics? Okay, people, does this problem, that's the first statement. I don't know, have seen the rating, but let's not bother about that, and let's try to give our best. Let's try to make points, okay? Let's try to make whatever the points. First question: does this problem seem to involve, yeah, but the order may be different. Ayusha. So Ayusha gave us something. Let me copy paste that. Uh, so first question: is it always possible to get a non-decreasing array? Are there some times when we cannot at all achieve non-decreasing array? But for that, we have, who is this guy? Ayusha, saying this one. If we do knock 1, 2 up to so on n, we get all zeros. So that's a non-decreasing array with max equals to 1. Who's texting me? WhatsApp. I have to close that. Oh, oops. I should not be showing these things. Fuck, I have to see what the fuck was there now. See, you also should live solve the problem, Suzanne. Okay? You also should live solve the problem. We use the concept of difference arrays in this question. Yeah, maybe concept of difference arrays or not, but we have to see the question itself. Don't go behind. Follow the stream. We have to see the question for itself. We need not even think of what may work here. Maybe difference array works or not. We need not even think about that. We can see the operation, what the operation does. We can see how to get the maximum max as a proof. Like how can we prove that this is the maximum max, that we cannot get any higher. We have to prove that among all permutations you cannot get any higher. So let's use our golden rules too, because if you are getting a solution to this prismax, you will also be proving. I don't have 9 plus GPA. I never had. In my only final sum I have tried. But people, no, see, my golden rules say solutions are simple, proofs are simple, implementations are simple. We are trying to use this for our advantage. Do you get what I mean? Even in this problem, instead of thinking randomly, now I can think, uh, how can there be a proof for any permutation to maximum max? See, we have to prove like for any permutation to maximum max. That means there is something about the operation. See, we are using simple to our advantage. So from any permutation, n factorial different or there, we must prove that what we found is maximum max. Right, we have to prove this thing, which means probably operation has some constraint or some restriction that makes this proof complete, because there is something like we can say whatever the permutation, this is the maximum max. We must be able to prove this thing. That means there is something in the operation that if it is a non-decreasing and if it is happen that exactly once, then this problem can be solved. That's what we get from proofs are simple. So if actually uh, if you are using all indices exactly once and also the final, then the problem is solvable. You guys have to take that. If there is a problem on code forces, that means that problem is solvable. That's why these are important, because the problem has simple solution, simple proof, and implementing solution. So okay, let's try to see about the operation itself, right? Let's try to see the operation. What is that operation says? Okay, let's try to just see that little bit. Kick AI to make next AI things plus one, right? And finally we have a non-decreasing array. See, non-decreasing array also says something about max, right? So a1 will be 0 finally, for sure, right? Because whenever you do kick a1, that is 0. So try to write down points too. Yeah, I saw that. I have even congratulated him. Like, congrats for becoming IGM. I told I will also become one day IGM. I know him. Like whenever when we went in ICPC, we have been like a bit together for some time. Like we went to dinner together and then we came back. Maybe were discussing some things. So I know Mrudul I quite well. Not quite well, but I know him a bit. So guys, focus on the problem, right? What do you mean even GM solved it in nlogin? Hey, Likit, don't spoil the problems, okay? Like, I don't get what you mean here. We are trying to solve this problem. They make my rating, they break my rating. At this point, I cannot give a shit about it. I think I will become Grandmaster, I will become an international Grandmaster too. So, guys, focus on the problem now. We have people focusing on the problem. So, if you see this, it's a okay. I will use this Excali draw too. If you see an increasing array starting from 0, 0, 0, 0, 1, 1, 1, 2, 2, 2. Let's say it's going like this. But at any point, if there is a break, If at any point like 3 is missing, that is the max, right? If 3 mixes, that's the max. So non-decreasing, the final result should be non-decreasing, actually helps in the max, if you guys see. Because everything given in the problem, if you see how a difficult question is having more logical things to fit and get the solution rather than one simple thing. So problems demand you to be able to use more logic, that's what they demand you, not topics. Understand, even a bit difficult problem, it's what is it demanding. You have to apply logic that okay, these are the operations over all permutations. If the final result is non-decreasing, then this is the proof that this is the maximum max. That's how the problem is. It's demanding you to apply more logic and it's not demanding you to any topics. So guys, it may take some time, but still let's try to give our best. We are how many? 31 people. Can 31 people solve this problem? Can 31 newbies and me? I don't think you all are newbies, I'm joking. Let's say me also a newbie. Can 31 newbies solve this problem or not? Let's try to do it. Knocking down AI towers before I might add. Okay, someone is telling some. Bro, focus here, bro. We are trying to solve the problem. If you have no intention, I wouldn't focus here. All of you try to read the problem. Newbie or not, try to read the problem. Try to make your observations. Knocking down AI towers before I might add AJ plus I, which is greater than A of J plus 1. Knocking down AI towers before I. Knocking down AI towers before I might add AJ plus I, which is greater than AJ of plus 1. I didn't understand that panemonics. Sorry. Guys, I will change the title to Can 30 newbies solve a 29? Can 29 newbies solve a 2900 problem if we solve this problem? See, it doesn't involve topics. One thing we can say is the gap we get, that is the max, right? See, few things we can see obviously. So 0 0 0 0 1 1 1 2 2 2 XXX, so on, sex, sex, sex. The first value that misses as it's non-decreasing misses is max, right? The first value that misses is max. Okay. So let's say whatever you do, max misses means you cannot get some zeros, some ones, some twos, up to so on, some max. This is what we prove. But you can get some zeros, some ones, up to so on, some max minus 1 using some operations. This is what we have to prove. Problems are direct. That's what I'm trying to show you people, that problems are not getting some great idea, but seeing the problem for what it is. Okay. Do you guys see how even in this small thing, it's about what you can work on. When you think you don't have anything to work on, see, we have this to work on. So we have to prove that okay, some zeros are possible, some ones are possible, but we cannot go till until some max. Whatever you do, you cannot go till there. You can only go till here. That's how it is. So let's try to see. So maybe we can have things for all prefixes too, right? Because the operation only goes on to this side, right? And we can have such a thing for all prefixes too, maybe, right? We can have that thing too for all prefixes too. Maybe thinking what's the answer for all prefixes. I mean, why is this helping? Because when you do operations, they all go to the next thing, right? They all just go to the next thing. right? And you apply everything only once. If you see some prefixes, when you apply all of them will be gone, right? First, let's also think of non-decreasing. How can you make them non-decreasing? Let's also think on this thing, okay? Let's try to think, guys. We have many things to think here, okay? Number of intervals crossing a range. If range is bigger, then max is bigger. Guys, there's more work here. There's more work. We have to also think of this non-decreasing, like, and then we have to also think of this thing. Okay. So what is the restriction of the order if you want to make it non-decreasing? Okay. Uh, let's say you have 0, 0, 0, 0. Okay. What happened to these zeros? Probably this came first, and then this came, and then this came, and then this came, and then this came. That we can say, right? Because this came before this. Oh, we can initially to have some zeros. Okay. We can initially to have some zeros. Mm-mm-mm. We should also prove. See, for these operations, there is something that makes you say this is not possible. Whatever you do, this is not possible. Okay. So let's try to see slowly. It should become non-decreasing, non-increasing. Okay. Okay, someone has told something important. Someone has told something really important, I guess. Who is this? Knocking down AI towers before I might add AJ of I plus I, which is greater than AJ of A of AJ plus. Okay, one thing we can say mathematically. So, of towers before J, before I. So, if you look at some towers that got knocked down before J, it's not simple again. If AI, if I got knocked down before, and at that time, if it can reach J, only then J gets influenced by it. See, this is also not simple yet. If some tower got knocked down before, it can have some more than AI value. And then, if that more than AI value, can it come here or not? Also, that is being dependent. So we have to still see the problem. Only logic can help us. I may take some time to, you may take some time to. So keep trying, people. It helps. Trying, have hope. It's just 34 minutes so far. Have hope. Maybe keep trying. It may help. Hi Sainath, there is problem link pasted in chat. Uh, try to read the problem. Try to give you a try. Okay. Bro, example, I don't know the solution yet. Let me try now. Like examples wouldn't help us. Examples, see, if you need fucking example, that means you cannot use logic. Force yourself to use more logic, okay? I won't give examples here. Force yourself to use more logic. It's helpful to use see example. Even I should see example. That's my mistake. But force yourself. It is not that complex. Random permutations, once you hit it, all of them will fall here. But the Structure is being complex because once you hit it, these things change, right? And then these things change. That's the only reason it's being complex. So we have to see when can we make it increasing. Let's try to make some observations because operations will only do plus one, right? One operation. One operation will only do plus one, right? So the final values will be in between 0 and n. Also, AI being greater than n minus I doesn't help because all of them go outside, right? That doesn't help. See, we can just make some points instead of. We have to understand the operation too. So, what does this mean? From L to R, all towers knocked down and each tower reach R, then all towers knocked down, each tower reach R, then max will be R minus L plus 1. Okay, if everything can reach R, okay, that's let me write that down. Let's say there is L to R. If kicking everything in this range reaches R, then you can have 0, 1, 2 up to so on R, making R minus L minus 1 R minus L, making max R minus L plus 1 is what has been told by him, which is very obvious. I think by this Shibe, you may be getting some example by this. Okay. See, it's difficult, but it may help you people. Even if it not solve the problem, it may help you people because successful streams are not me solving a problem. Successful streams are like we trying to learn something. Okay. So don't be mad. For two elements, AI and AI plus 1, if some towers before AI can reach add 1 only till AI, then there exists only AI plus 1 minus towers like that. Yeah, this is also a good point because uh, towers are falling. Let's look at AI and AI plus 1 because there is a restriction that they should be increasing, right? So let's look at AI and AI plus 1. Whatever the previous towers have fallen, most of them. Let's look at AI and AI plus 1. Let's look at just both of them. Okay. So what he is saying is if some towers before AI can reach this one, it will be increasing, right? Only if they come only till AI, only then it will only that then okay. So that's what okay. Someone long back told difference arrays makes sense, guys. I'm actually not thinking. I'm not thinking deeply because I have to keep talking, right? Because I have to keep the stream entertaining or interesting, right? If I try to think deep, if I try to take a pause and think deep, it may go waste. So actually, I'm not thinking here. You guys are thinking. So someone long back has told me to look at difference arrays. I have neglected them, but yeah, so this seems difference array seems useful, right? because we want AI minus 1 minus AI greater than or equals to 0 finally, right? So difference seems for it, and also operations would not affect this value much. And finally, we have our final difference array is, so seeing difference array is good here. Who told me that? I have to give shout out to them. Uh, 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 Someone has told Prismax, I think, or else someone else. I don't know. Yeah, we can find them. I think. I don't. See, I think Chaitanya none of the different arrays makes sense. See, Pandemoniacs has also told some statement. If you see, Abhay Tiwari, you get what I give. Okay, I'm just joking. So focus on what I'm telling. Is this clear now, people? I'm giving something that you can get nowhere, and then you are telling me to do something else. Fuck, fuck, fuck. Is this clear to you, Ari? Is my connection good? So, whoever told difference array is good, because we even have this guy telling us, Pandemonics telling us, fuck, what the fuck is this? Yeah. So Pandemone, this was told by Pandemone, this was told by someone else, Laksh Mohit, I think. So it's not a difference array idea, it's just an observation to look at this thing, because if you see they are falling like this, right? Their things are falling like this. So if you finally see AI and AI plus 1 adjacent things, if it falls on both of them, the difference doesn't change. So from operation we can see that if some tower falls on both AI comma AI plus 1, their difference doesn't change. Adjacent difference. If it only falls perfectly on AI, then this value changes. See, from this operation, this is coming. From this operation, it's coming to look at difference array. It's not like difference array idea. Again, don't get topics or ideas into this, because this fact says to look at difference array, and that's exactly what he's telling here. For two elements AI and AI plus 1, if some towers before AI can reach only till AI, then there exists only. Oh, he even made a much more logical statement, but what simpler we can see is, let me try to see if this is correct again, but what simpler we can see is, if some tower falls on both, then the difference doesn't change. If it falls perfectly on AI, then this value changes, right? Finally, AI plus 1 will also be gone, AI also will be gone. So if AI falls Also, AI can affect AI comma AI plus 1 in a weird way. If AI greater than 0, it makes AI plus 1 as it increases only AI plus 1. Else, if AI is 0, then it doesn't change. So let's look at AI plus 1 minus AI. Okay. You people have bad internet. Don't blame me. Okay. Let me check. So whoever told different arrays, it's not different array idea, but I hope like we have a pandemonics following and Yashmahota following. Is pandemonics there? Fuck. I'm not a Takes fan. I don't know why that guy appears on my screen. Okay. It's not lagging much. It's lagging a bit, but it should be adjustable, right? Hey guys, it's true that it's lagging. It's true that it's lagging, but let's adjust to that. Fine. So if you look at this, if some tower before I falls on both, then bi doesn't change. Falls on I but not I plus 1, then bi equals to minus 1. Okay. If tower I falls, if ai greater than 0, bi will become plus 1. Else bi stays same. So this is very restrictive. If you guys see, this is very restrictive. Tower I plus 1 false, that doesn't affect final. Maybe Yash Mohta, maybe it is, but we have to prove things clearly, right? Uh, let's go slow too. We need not hurry too much. Okay. So is there pandemonics? Where did he go? He was saying something. Oh, he's there. Switch to 480p. I didn't see him. Okay, so we have pandemonics and Yash Mohta that are trying to be active. Other people too, but yeah, Shibe is also there, but he's busy switching or blaming lag. So is this statements clear, people? I will wait some time. Are these lines from 121 to 137, are they clear? See, we want final bi greater than or equals to 0. But if you see, it's reducing most of the time. Let's say bi 0. Initially bi equals to 0, let's say, because finally ai plus 1 is going, ai is also going, right? So finally it's 0. Now bi is reducing most of the times. It is increasing only once. It's increasing only once. That says a lot about these things. That says a lot. That's very restrictive, right? To keep this shit increasing, it's very restrictive. If you guys see, it's very restrictive, right? See, what does that hint? It hints we can solve this problem without using any fucking topic. Okay. I'm ignoring random weird doubts. Okay. Like Shai Swish Fishy Shoe is asking. Is there lag still? Nice, that's a nice thing. Let's work on the problem. Okay, we can work on the problem. Now we have found something to work on the problem. So if we look at final difference array bi, that bi will be all zeros and it can become -1 only if something falls on I and not on I plus 1, and it can become +1 only if I is greater than 0. Only then it can become greater +1. So only 1 plus 1 chance is there. You see, most of the -1s are there. So final difference array is important. Let's call it bi. We have seen the operation, right? Now let's see max in this. We have 0 0 0 1 0 0 1 0 0 1. So if you see this 0 0 0 1 1 1 2 2 2 2 2 3, let's say, this is how final difference array will look like, right? And the moment you see something greater than 1, then max equals to number of ones before this point plus 1. So we want to maximize this number of ones before something that appears which is greater than 1. But can anything be greater than 1? No, right? How can something be greater than 1? No, that cannot be greater than 1 at all. Is it that simple, this problem? Guys, help me out. So that's, I mean, we are only getting plus 1 once, right? We only get plus 1 here. Bi can increase plus 1 only once. Bn is not there. From b1, b2 up to so on bn minus 1. So paramonics, hey paramonics, you guys should inform me if there is a lag, okay? I need water. So can you please confirm? I'm sorry for just asking one guy, but that's convenient for me, right? I can at least try to explain one person so that others will understand or can follow up. Yeah, there's no lag, but can you confirm that there is only 1 plus 1? Let's see examples now. Okay, here the final is 001, 0012. There is no big jump at all. And if you see this, most of the time we only get once bi plus 1, and most of the other times we only get minus ones. Right, we only get minus ones most of the other times. We only get ones plus 1, which means there won't be any greater than 1 at all. So final b, array b equals to 0 1 0 0 1 0 1 0 up to so on has only 0 comma 1s, and max equals to number of ones plus 1. So our goal is to only maximize number of ones. It's that simplified now. So it's that simplified. If there existed continuous non-increasing from front from the end, I didn't get you, Pandemonics. It's 11 viewers, but let's try and solve this problem. At max 2 hours we can go. Okay. See, we already solved the half solved the problem. Now what's left? Working on bi minus restricted bi minus 1 operations. See, we only get bi plus 1 when ai equals to 0, a greater than 0. So there's already an upper bound on answer. So this is an already upper bound. Do you guys see that? Is it being too difficult? Till here, are you guys able to follow till here? Because I would not understand if something is too difficult, right? See, towers fall. The final value of bi and bi plus 1 only depends on if some tower fallen exactly till I, and it will only increase when ith one will fall. No, bro, don't ask me anything. We are trying to solve the problem, okay? Rakshit Negi. Panemonics, can you say what you mean? So we know what to work on. We can work on the restricted. So this is an upper bound. That's an upper bound. Like, that's an upper bound because, so if we take this example, let's say 1, 2, 3, 4. 1, 2, 3, 4. Number of things greater than 0 is a lot, but we only got 4 because there are probably stronger upper bounds. This is an upper bound. See, guys, yeah, any tower can fall exactly once, but this is an upper bound, but we need a stronger upper bound. And what we can work on is we can work on this thing, restricted minus ba minus 1 operations, okay? So if ai equals to 0, there's no way bi can become plus 1. If ai greater than 0, still we should work now. Bi will surely become plus 1 because when this tower fallen, see, there is something more probably here, and not something more. See, this is a bit complex, right? When so now we have to make sure that this will surely become plus 1. Now we have to make sure that see that bi decreases at max once, and we should also limit. We also want minimum such things, right? BI will decrease then Aisha. That's what we have been working on. From is AI plus 1 minus AI. Okay. AI is AI plus 1 minus AI. If something falls on AI, BI will reduce. BI will increase only when AI goes and falls on AI plus 1. Only then BI will increase. Okay. So let's say towers have BI equals to AI greater than 0. So if AI is greater than 0, there will be 1, else there will be 0. Now, so one thing is clear. Only one tower can fall on I at max if BI equals to 1. Fall on I. What does fall on I means? If something falls exactly on I, let's call it fall on I. Okay. If something falls exactly on I, we call that fall on I. Only 0 towers can fall on I if BI equals to 0. Like, okay, let me keep it like that. If AI greater than 0, if AI equals to 0. And minimize number of towers that fall. This is what we have to minimize. So this is what we have to minimize now. We want minimum number of towers that fall on something less than or equals to n. These are the restrictions. Only one tower can fall on something. Only 0 towers can fall on something like this. And then we want minimum number of towers that fall on something less than or equals to n. Are these statements clear? Pandemonics. See, this makes sense. This make it very simple. It's not the fall that matters, it's where they fall that matters. That's it, the idea. And where they fall, two things cannot be falling on same thing. Only one thing can fall on something. And sometimes 0 things must fall on something. See the restrictions. And we have to minimize number of things that fall on these things. So, which means we want most of the things to fall after shit. Okay. We want most of the things to fall later. Frequency of falling? What do you mean frequency of falling? Everything falls exactly once, and we want most of the things to fall later. So, restrictions. If restrictions are satisfied, we want to minimize or maximize the number of towers fall greater than n. This is what we want, because if the restrictions are satisfied, answer is number of ai greater than ai greater than 0 initial ones minus number of towers fall greater than n. So this is the answer, right? If restrictions are satisfied, this is the answer, right? And what are restrictions? Only one tower can fall on I if ai greater than 0. Only 0 towers can fall on I if ai equals to 0. These are the restrictions. After these restrictions are satisfied, this is the answer. Number of ai greater than 0 minus number of towers fall greater than n. Guys, it's difficult. Only 8 people, 7 people out there. It's not that easy to solve a very high rated problem on live stream explaining to people. So be active, respond, somehow respond. Fi- but how do we? Max is just number of ones, right? Hey, max is just number of ones. If you see here, you just need more ones. Panemonics, be responsive, please. You can save this stream, okay? Everything falls. Yeah, you can help me, Kailash. Thanks a lot for that. So, Kailash, do you get the point then? Do you get that? See, here, finally, we have zeros, ones, and so on. Greater than 1 also cannot form because we have more minus ones. We have only 1 plus 1. Bi can only increase ones. So now the answer, max is nothing but number of ones before this point plus 1. Panemonics, is that clear that max is nothing but number of ones plus 1 in difference array? Oh, let's listen songs. Are you lonely? While my heart's inside my throat. Why sorry? I didn't get you, Panemonics. Yes, sorry. It's probably yes, sorry. Okay, got it. So you see, max is already simplified, and now the restriction is that fall on something. Fall on something can happen only once. If AI greater than 0, it can happen only once. If AI equals to 0, nothing should fall on that at all. These are the restrictions. And once these restrictions are satisfied, we want minimum number of towers. We want maximum ones remaining, which is if a tower falls on 1, it becomes 0. So, which is nothing but we want minimum number of towers falling that fall on something less than or equals to n. This is what we want. Minimum number of towers that fall less than or equals to n is what we want. We want them to fall outside. Wait, I fucked up something, I think. I fucked up something. Pam 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 pam. I fucked up only one thing. Bi will also reduce. At least it's not increasing. This will also reduce, right? So, if tower I plus 1 falls, so let's make this very clear, okay? I can see things. So, what matters is, so I guess let's try to make it very clear, okay? False on I before I falls. This is what matters. So, false on I after I falls. So, false on I after I falls. Okay. Is bi equals to ai greater than 0 minus false on I after I false. Is this correct, people? Is this perfect? Just tell me. Why minimizing false is because see, fall on something is a terminology I'm using. Fall on something is a terminology I'm using, right? Fall on something is a terminology I'm using because falling on something will reduce the value. If something falls on I, bi will reduce. So now we have ones. Okay, let's say we have ones, and then we want to minimize number of towers that fall on something less than or equals to n, which means we want most of the towers to fall after greater than. See, we want to maximize the number of towers that fall on something before they have fallen. No, not this is also, but is this correct? Guys, it became little bit complex because it's all about seeing the operation. What Pandemonics did long back, it's all about seeing that operation. Like what he has done long back, it's all about seeing that, but we have to be a bit more careful, okay? The thing is, falls on I before I falls doesn't matter. This is the thing because they don't affect final bi value. Why? Things have fallen on I. It is reducing bi, but then once ai falls, that's gone, right? That's gone. Yeah, this right. So if ai value before falling is greater than 0, that will increase bi by plus 1. And now from this point, number of things that fall on I will reduce bi. See, this is one. This can be many. We want to minimize these things. Do you see? We want to minimize these things. I have already explained how to see the difference array long back. Because if you see the operation, if some tower falls on both, the difference doesn't change, right? From there, difference array comes, okay. If you are fucking paying no attention to the question, then you cannot find it. Kailash Chowdhury. This makes us to see that because plus one plus one plus one plus one is not changing most of the things difference, right? It's only changing difference of that far, somewhere there, right? That's why difference is coming into picture, okay? I'm sorry if I cannot solve this problem. So we have to solve the problem. We can take some time. This is not just BI. See, one thing is clear. BI, most of the times it's reducing. There is some other things too. Is this it? Is this it? See, it's difficult. Logically, it's difficult, but it's just logic, right? So let's try to push ourselves to understand this. Even for me, it's not being too easy, right? Because I'm talking to. So let's try to understand that. Is this it? Let's try to see very clearly. Okay. I plus fun. These are the two things that we are seeing. I plus fun. Yeah, yes, that's what we are trying to apply, right? See, it can increase. So bi greater than 0. So we will see two things. I plus 1. Let's say first this one is falling. This has fallen down. Okay. Bi. Array B. So once this has fallen down, what happens? This will become plus 1. If at this moment this was greater than 0. So if a value before falling greater than 0, then we get plus 1. Because this increases, this doesn't increase, right? This becomes 0. This becomes, yeah, this becomes 0. This becomes 1, right? And then, right? And then, whatever falls here, or whatever falls here, whatever falls here will become, will make, sorry, yeah, it will make, okay, a final a final, it will become plus 1 once this falls, if it is greater than 0. B, let's look at B. Then what happens? Plus 1 happens. B is nothing but ai plus 1 minus ai, right? So from this moment, if things keep falling here, if things keep falling till I, if things fall on I, what happens? This increases, but this doesn't. So that makes minus 1. If something falls on I, if something falls on I after I has fallen, that makes it minus 1. Okay, after I has fallen, if something falls on that, that makes it minus 1. Right? Because, okay, now falls on I means exactly falling on I. Okay. after I has fallen exactly falling on I. But if, hello, for I greater than I plus 1, for I greater than I plus 1, it doesn't change, right? Fall on I means the lost value got fallen on I. So there is another thing here. After these things. So after I fallen, so we have two key points. I fallen, I plus 1 fallen. These are the two key moments we have. And if you look at B, once I fallen, it will become plus AI greater than 0 at the moment. So it's at max plus 1, at max plus 1. But then fall on I will make it minus 1. Even fall on greater than I will make it minus 1, because fall on greater than I, what happened? It has fallen here, but then this will again disappear, right? So it's nothing but falling on I. So even that gives minus 1. But after this, only fall on I gives minus 1. This is what Pandemonics told in the long ago. Fall on I matters. But then there is more to that. We have to see from the point I fallen to the point I plus 1 fallen, and plus 1 happens only if I greater than 0 at this moment. Minus 1 happens if something falls after that, minus 1 happens. That's too bad. Too bad minus 1s. We have to just be logical. Minus 1s are too scary here, too bad here. And we cannot have two minus 1s at all. We cannot have two minus 1s at all. And after I plus 1 fallen, fall on I, fall on greater than I will be 0. So is this clear? Is this understandable? Yash Mohta, see what does this demand? If you see what does this demands your mental capacity to apply logic, right? If you guys see how I am able to do these things while explaining, while talking, you can see the difference. Okay, do you people realize the skill in thinking deep, being able to think deep? It's by practice, by forcing yourself to think more, you increase that. It's all about trying. You never try to do that, or you try to do that for years. Try to think a bit more for years. Like even here in this problem, we could have just given up on the problem, or we could have seen things clearly. Okay, these points are becoming mattered. Like when I false matters, when I plus 1 false matters. So let's try to see logically what happens once I fallen. Once I fallen, that will contribute to final plus 1 on bi plus 1, because that's the only time it contributes. But if I plus 1 has not fallen, again whole a plus 1 will go, right? So false on both of them also will make it minus 1 if this has not fallen yet. So it's all about trying to force ourselves to see what happens by keeping these two timestamps here. We could have just not tried to see this, and then we could have thought, okay, it's becoming complex, let's leave it. It's not complex. If you be clear, it's not complex. So let's see what happens if I plus 1 falls before. I plus 1 fallen here. I is falling here. Let's see what happens here, okay? I plus 1 fallen here, which means AI plus 1 is 0 already. Now, if AI greater than 0, here we have plus 1. But false on greater than I doesn't matter. They are 0. False on I are always minus 1. So this was our original problem that I thought. I thought that's the problem, and then I tried writing these things. But then that's not the problem. Problem has more, because if I is falling before I plus 1, in between them we have to worry on false on greater than I2, because they are also minus 1. But it's more restrictive, right? It's more restrictive. More restrictive is good for us, because we want finally greater than or equals to 0. We want more plus ones finally. Number of plus ones is the answer finally. Max is nothing but number of plus ones finally. We want more plus ones. But what's happening? We are mostly getting minus ones. We are getting plus 1 only here. Is that being clear? Yeah, maybe binary search, but see, you can smell. But rather than binary search, I still see we should apply logic in understanding the structure of the problem, like in understanding the structure of these things. Like, we cannot have fall greater than I. That says a lot, right? Before I plus 1 has fallen, you cannot have two things falling after that. See that? This says that I plus 1 should fall before something falls on that. See, that's very restrictive. Before binary search logic, how can binary search to magically help us? No, right? Logic. We have to use logic. Damn, I'm screaming. So, guys, before I plus 1 falls, before I plus 1 fallen, we cannot have anything. We can only have one thing falling greater than I. That's very restrictive, right? That's very restrictive. So there cannot be anything that's crossing that from before. There can only be one. There can only be one, but there cannot be two. Fuck. I'm not thinking. That's mistake. So these things will do plus one before this has fallen. So the main idea that I am hoping that we have less plus ones is gone. I should have just seen examples as Shabi told me, but still let's not back down, okay? Who is that guy told me to see examples? See, even though we fucked up, we still have thought on the problem. So we can proceed further. Shibe. As Shibe told, I should have seen examples. Ah, sorry, bro. Before I mean, I am not at all thinking because, but still, we have thought of the problem this much. So just this, even though our thought that plus one is less has gone wrong, still the problem is solvable, right? Still the problem is solvable. It's on code forces means it's solvable. So still let's try that. Okay. So fall on greater than I plus one matters here. That makes it plus one. Fall on after I plus one has fall on I matters. Only this matters. Fall on less than or equals to I doesn't matter. Fall on I only this matters. Nothing else matters. So if it's fall on greater than I, fall on I. Right? So we have two types of falls. Always. Fall on I, fall on greater than I. So before I fallen, we have two key moments. Before I fallen, we want greater than ice. So this also brings greater than 1 here. We also don't want greater than 1. So this brings greater than 1. So that makes number of points. This as correct. This is wrong. So these things are a bit wrong. Commenting inside of comments, but this is right. Now we can have these things too, and still we want these things to be maximized. Right? Still we have came to this extent, right? We are able to write everything in terms of not everything. It's still complex, but see, it's complex because we haven't applied logic yet. If we apply few more logical points, maybe it gets simplified. Because we don't even want plus 2. If you make a plus 2, the problem ends still here. If you make a plus 2, the problem ends still here. Okay. We haven't even tried this idea of trying to find the answers for all prefixes. So even if it goes some more time, let's try our best. Okay. Let's try our best. It's not that easy problem, right? See, till here it's looking complex, but it will get simplified. Because it should get simplified. We can see this in some way that makes it simplified. Okay, we can see this in some way that makes it simplified. So let's try to see that. So even this thing goes here. This is also nothing but this, right? Do you agree that? This is nothing but this, right? Guys, are you getting me? Don't irritate me, please. Sorry. Pandemonics. This thing can be removed. Do you agree that? Because this is nothing but until this point, AI falling on I plus greater than I, right? So that can be removed. Okay. That can be added to here. So that can be added. And then fall on I will become -1. Fall on greater than I also will become -1. So this is nothing but fall on greater than or equals to I. For on greater than or equals to I is minus 1. And then for on I is minus 1. Right? After this point, pandemonics, let's try this problem a bit more. Let's 15 minutes or 20 minutes because things will get simplified. Things will get simplified. We have to just see what this means, Fall on greater than I for before this has fallen, right? All of them will be plus 1. And once this has fallen, so we have, let's say, let's say I'll go to washroom in a minute. I think we need not worry about plus 2 because what, let me write, most of this is wrong. If bi greater than 1 means we need answer for prefix 0, 1 up to so on I. This max is the answer, right? If this is so, that brute force can be done always because things fall forward, they cannot affect the behind array. So let's assume that bi is becoming plus 2. Let's assume that bi is becoming plus 2. Okay, let's assume that bi is becoming plus 2. That means we want prefix answer without becoming plus 2. Maximum number of ones without plus 2 for all prefixes. If you find this, you're done. Because if you find this thing, something becoming plus 2 or not, if it's becoming plus 2, that means answer of prefix is what we need. So finding this for all prefixes is enough. So the problem is again zeros or ones, but for all prefixes. Uh, is that fine till here? Pandemonics. Say yes once, please. I'll go get some water. I'll go to Susu too. Think sometime because go to washroom. I have still hope that we can solve. Hope you guys should too. I'll go to washroom and come. First washroom or water? I'll get some water now and then I'll be back. So we can still work on 0 and plus ones itself. So, guys, I have drifted a bit because I thought this is a really good observation that we only get. I thought, like, whenever that happens, I thought, like, it's not becoming plus one is a really good observation. I thought that's why I have betted on this and then I have came in this direction. But then, if you have been careful, we would have realized that it can become plus one more number of times, right? It can become plus one once AI falls. Anything before AI falling helps it. That's the mistake we made, right? I'm just trying to see this in a better way. Okay. I'm just trying to see this if this can be seen in a better way. You also should just try, like, what are all the cases? How to think I can just talk. I'm sleepy. We only things greater than I, at I. Only those things matter. And then I think, see, I really believe we can see the problem in some other better way that simplifies things. Okay, I really believe that. I came to this because I thought there is only one minus one. I mean, only one plus one. So now let's try to see some other things too. Okay, this is enough analyzing. Let's try to look for more observations. Uh, See, this is just analyzing. This is just working on the operation, right? This may not be needed. Like, working to this extent may not be needed. Maybe something else simplifies the problem. So we have to sometimes think, if I am working too much on the operation or not. Like, if it's not getting simplified, we have to stop and then go to something else. Like, not something else, maybe something else that simplifies the problem. We want it to simplify the problem, right? So let me once try to see this in a simpler way. If not, we will find something else that solves the problem. Okay, something obvious itself, not too weird. I hope we can solve this. Not just hoping, we will solve this somehow. We have to hope. Even if we don't solve it, it's fine. I'll end the stream in some time. 2 hours it's been, right? It's plus one. Wait, wait, wait. Is this really plus one? No, right? Because Finally, this is gone, right? When I plus 1 falls, this is gone, right? When I plus 1 falls, whatever has fallen greater than I is gone, right? So this thing doesn't matter. So it's really fuck. Fuck. There is no plus 1 at all. Wait, what's happening? Is there no plus 1 at all? If I plus 1 falls after I, is there no plus 1 at all? I fallen, I plus 1 fallen now. From this point, there is no in this case, I fallen. I may increase, but then I plus 1 fallen. So now I is greater. Bi is negative, less than or equals to 0. So now both of them has fallen. Now whatever falls on top of it, so we're true. There is no plus 1 at all in this case. There is no plus 1 at all in this case. So guys, I'm sorry, but pandemonium, can you say yes again, please? So guys, we are back to our previous hope. Okay, problems cannot get too complex as we see here. If there is no plus 1 at all, if there is no plus 1 at all, that means no minus 1 should also not happen. See people, we can try to see example, we can try to understand the real structure of the problem with that. But I am somehow, in this way I try, and that's my fault. That's the reason I fuck up sometimes even easier problems. I will go into some mathematical trap by thinking something wrong, and then I can never recover. That's my drawback. I have to somehow correct that. Okay, that's why I'm not like grandmaster or international grandmaster, but not just that. But yeah, here, even if AI falls, that's gone again when AI plus 1 falls. I plus 1 falls. So there is no plus 1 at all here. Okay, so this case is very restrictive. So the fact that this thing I thought, because I thought like when it is gone, these things became plus 1, but immediately like when this has gone, that's gone, right? So final plus 1s we are trying to see. These things will not contribute to final plus 1s. They contribute intermediate just after I fallen they appear, but then they are gone. Again, when I plus 1 has fallen, they are gone. So here only minus 1s are there. Even this is gone, or what? No, this is there. Greater than or equals to I is there. From this point on I is there. But all these are just minus 1s, which we don't want at all. For the final B, we don't want any of this happening. If I plus 1 falls later, that's very restrictive now. Do you guys see? So our original idea stays the same. I thought my carelessness was the reason, but that's not my carelessness. See, when pandemonics has told in the very beginning that it's being restrictive, that I plus 1 doesn't change, then itself we know that this is the way, then itself the problem is solved, like there is no other way. But then I thought like we have to be a bit more careful in doing things. See, carefulness is really important a bit. We don't need muscles to solve the problem, but why not get something when you can get? My CGPA was bad, but if you put little bit of efforts and then if you can get CGPA, why not get that? If you can put little bit of effort and do some push-ups and then if you can get muscles, why not get that? You have to be like that, guys. uh, because it doesn't demand time, it demands consistency, right? I am able to solve problems even though when I am not uh, practicing all day. If people lie to you like you have to solve 500 bullshit lead code problems, I don't really think, I mean, for us lead code should be non-reasonable, right? If we solve this problem, this becomes 14, this 13 becomes 14. So big progress there, right? And this seems obviously solvable. We all have yes, yes, yes. We are here in the comments. So yeah, let's look at this thing now because this is very restrictive, right? So I plus 1 fallen. Let's look at this very carefully now. See, it's not that difficult to look at these things. This just demand our logical capacity, right? Because we are just looking at I and I plus 1. We are not even looking at the whole thing, right? If you look at I plus 1, fallen. First I plus 1 has fallen. One of them will fall first because everything is fallen at least once, right? So I plus 1 has fallen. So I will also fall. So here AI plus 1 is 0. And whatever AI has doesn't matter. All of them is going to disappear, right? So greater than I will make it plus 1 to the final value. Till here greater than I will make it plus 1. And after this has fallen, now equals to I will make it minus 1. Am I right? So I plus 1 fallen before, let's say. So everything that comes and falls on I greater than I will make it plus 1 plus 1 plus 1. Right. Previously I missed this. I plus 1 fallen, it became 0. Everything that falls on it will become plus 1 because this is going to go away. This thing is going to disappear. So all of this will be, so this became complex. This didn't become complex, but this became complex. But still, let's see. These things must be made, right? These statements must be made. This is very restrictive. But then this I plus 1 fallen first. So this says something too. So let's see this. And then if I falls, anything that fallen on greater than I will make it plus 1. Everything that after I falls till here, till here. If everything that falls greater than or equals to I, but after this, if everything that falls on I will make the value minus 1. So this is right. And we want these things to be equal or this to be plus 1 of the below thing. Right. So let's look at these two things. After this has fallen, we want, after this has fallen, we want almost equal number of things falling after and falling on this. See that? We want almost equal number of things falling after that and falling on this. Does that say something? Almost equal. Would this restrict like some log n kind of thing like by 2 because we have half the things later and almost half the things here? Maybe not. Let's not worry too much. Let's try to see logic itself. Here it's restrictive, but here we have many plus ones, we have many minus ones. So still we have to solve the problem. Let's try to solve the problem, okay? We can solve the problem. Guys, let's hope we can solve the problem. So let's try to see this. Or we can try to make, we have to think of the problem in a broader sense too that I'm not doing. I'm just looking at small, small things, right? So if I plus 1 has fallen, all these things matter. And then we can assume without plus 2's happening, what's the maximum number of plus 1's you can get? If you can solve that problem for all prefixes, you're done. Without plus 2's happening, what's the maximum number of plus 1's you can get? So we have to still hope. I think if we fail here, it's fine, I guess. It's still a difficult problem, and then we did something at least. But we won't fail. We will somehow solve it. Okay. See, we just need a better upper bound that restricts our maximum. So let's try. Let's think for some time. Please be calm, be cool. We can think. We can do this. Okay. So we have here restriction, right? Let's try to use that restriction. Okay. Uh, I plus one fallen before. Okay. So let's say this has fallen. So this is the first thing has fallen. Okay. Let's say this j. That means for almost all of these things we have that restriction, right? We have that restriction to almost all of these things. What is that restriction? If this has fallen, what is the restriction? Sorry, sorry. We have restriction on all of these things, right? Because if I plus one has fallen before, okay, this is the case. If I has fallen first, that means the restriction is happening on I plus one falling later. So let's say j has fallen first, j plus one has some restriction now. So if this has fallen first, that means we cannot have, if this has fallen first, we cannot have anything falling greater than or equals to this here. It seems we cannot have anything falling greater than or equals to here. If this has fallen, see that, because if this has fallen, this became 0. If anything becomes greater than or equals to, what happens? This hasn't fallen yet. It is going to become 0. In all those cases, this is going to be more. And after that, it cannot be helped again. See, so let's focus on the restrictive thing, okay? If J has fallen, that says nothing can fall after this. That's a very big restriction, right? Nothing can fall after that. If J has fallen first, this is probably a failed stream, but still, let's try. Anyone's there still? I don't feel good today. Somehow stomach is hurting. Have to sleep too, but let's try. Let's try some more time. Maybe at max by 2 hours 30 minutes I'll pack up. I mean, we don't know that, right? That can be before numbers j has fallen now. We don't know anything about that, no. I mean, j has fallen, but it can be increased later, right? Okay, I'll try to use whatever he's saying. If j has fallen, became 0. So what does that mean? So let's look at where j has fallen before j plus 1. Okay, j has fallen before j plus 1. So now j is 0. And we cannot have anything falling on j or j plus 1. See? Let's look at j has fallen before. Let's look at a case where j has fallen before j plus 1. Okay. Let's look at this case. I think whatever he's saying is right. J has fallen before j plus 1. Now this became 0. We are here. J has fallen. This hasn't fallen yet. This became 0. Now this is going to fall. This is going to fall. Then it becomes 0. Then it becomes 0. Right. in future it's going to become 0. Means we cannot have anything falling here. We cannot have anything falling here too until this falls. Right. But the thing is, this will increase when this falls. When this falls, this can increase. So it won't remain 0. We cannot use that. We have to look at BIs only. We are trying to look at AI, right? We're trying to look at AI being 0. And then once this falls, these things can increase both of them. So then it will recover. Once this falls, then both of them can increase together, right? So, but one thing is obvious: if j falls before j plus 1, if j falls before j plus 1, then we cannot have, until this falls, we cannot have anything appearing here, okay? Even or here too, or here too. So, until this falls, whatever the falls happen, they should happen within these things only. But after that, until then, this is 0. Okay, until then, this is 0. Whatever the falls have happened here. But after that, whatever falls, they should happen on both. After that, they have to happen on both. So, what does this mean? Does this mean if j falls before j plus 1, that means we can see them together? Is that what it means? Because not together, like whatever falls, nothing should fall on here at all. Nothing should fall on here at all. If this falls before, because if something falls, it goes minus 1. This increases and then it will never decrease. So that means if this falls before this, somehow nothing should fall on this. That's the restriction. That's the only restriction. If j falls before j plus 1, nothing should fall on j. That's the restriction, I think, right? Even here, what we wrote, if I falls before I plus 1, even this should not happen. Nothing falls on j. Before this goes, nothing falls on here too. Nothing falls on exact j. Before this falls, nothing falls on here too. We're not getting anything. Yeah, I get it. But then all of them may increase later, right? If j has fallen, something else could have been bigger, could have increased everything now. So if j has fallen, the only restriction is we cannot have anything till here before this falls. Anything here before this falls at all. Means until, if let's say j has fallen before j plus 1, until j plus 1 falls, until j plus 1 falls and becomes 0, this side is totally independent, like it's totally being onto itself. Okay, until this, let's look at these two zeros. This became 0, and then this will also become 0, because Nothing should fall here and at all. So if this becomes 0, this should also become 0. Until then, nothing falls on top of any of those things, because once this becomes 0, if something has fallen on top of these things, this will always remain higher, right? So if this has become 0, this will become 0. Until then, nothing can happen to this. See that? At least that's something. At least this is one point we got finally. It's late, guys. If any new person hasn't liked, maybe like the video. I will see those likes tomorrow. Have to sleep too. But let's try a little bit more. This is fine, right? If this has 0 and j plus 1 has fallen later, that should become, until these two are zeros, nothing happens on top of them at all. Some things may happen here, but nothing comes onto these things. Okay. But let's say something is happening here. Can't it wait until this goes? Think of that. Because anyway, it's not affecting these two. Anyway, it's not falling here. So if something is happening here, why not wait until this falls? How's that? That's some logical statement, right? Do I make some sense? Panemonics. So if this has become 0, I mean, this we could have seen earlier also. I don't know why. Let's say j fallen before j plus 1. Okay, we have few things falling here and then this falling. That's fine. But once j has fallen, left side things cannot influence right at all, because if it does, it's gonna fuck up. So left side thing doesn't influence at all until this falls. Until this falls, it doesn't influence at all. Once this fall, then it can fall on both of those. It can fall on both of those then. So until this falls, it can internally fall. It can internally fall, but why do that? You can just wait the same internal falls, and then once this falls, you can make them, right? Because those things will not affect this at all now. So this says something. So if j falls before j plus 1, after j falls, you can have only these operations, only this side operations. And once j falls, you can come to this side later. You see that? How much later? Until this falls. That much later you can come. Right. That says something now, at least. What is Harsh Mishra trying to say to me? So this says something, right? So if first 0 appears, first this one falls, the left side part cannot influence the right side at all until this falls. Until this falls. That says something. That says something, right? Because until this falls, it cannot affect at all. And once it falls, then it cannot, it must fall onto top of both of these things. That's another restriction, okay? So this has fallen before. Let's say this has fallen before this. If this has fallen before this has fallen before this, the things that have fallen before that, they may influence the other things. So those are valid because they can have their influence on these things probably. So the things fallen before this have some uh, they can have some influence on these things. Okay, if j has fallen before j plus 1, the thing, once j has fallen, these things could have fallen before, but once j has fallen, we need not do anything here until j plus 1 falls, and until then both of them remain 0. So this says something. What does it say? Let's say this has fallen before that, 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 and so on. Okay, for all of these things, once this becomes 0, and then this will become 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 0, and only then the previous things can come. Suppose if this fallen before this fallen before this fallen before this, and all anything that falls must fall till here now, after these things. So if this has fallen before this, so if this falls later, it must fall after all of these things. That's one thing. So if something has become 0, if something has fallen, it becomes 0, that's definitely bad for us, right? So we can just look at that simple fact. I don't know why I have complex this problem a lot, but if something has become 0, that means from this point, if something has become 0, let's look at the last 0 at any point. Okay, let's somehow, these are all increasing. All of this has been fallen, and then this has fallen. Okay, let's look at that. Maybe that says something. Maybe or all of this have been fallen, then this has fallen. Also that says something. If all of these have been fallen and this has fallen, that seems bad, right? Because all of this have been fallen means they may be greater than 0, and then if this falls, that's fucked up. We cannot help at all. So what does this mean? Once this becomes 0, once this becomes 0, there can be some non-zero here, but then something else may fall, and then that may increase this. We are not getting this at all. There's no teaching here. Guys, we have to do something. Let me think a bit. Let me think a bit. Let me think a bit. For 5 minutes, I'll try to think a bit. Okay, I have to sleep too. If this has fallen first, we have these things, and then let's say something else falls here, zero. If some other thing falls here as zero after this has fallen, until this becomes zero, we can pause them, is what we know, right? But before this becomes zero, if something else, if this has become zero, then uh, then then let's look at it. Before this has become, if something else has become zero, maybe these things will help it. Maybe these things will help it. Yeah, that's what, right? Maybe some other things will help it, and then falling exactly here is the bad thing that can happen to this. That can happen to this difference. Can we try simple ideas like if you have answer till I, can we get answer till I plus 1? Most direct answers because we may be missing something. Uh, we can pause this video. It's fine. Stream fails happens because I'm risking, right? Otherwise, it will be some other post contest discussion of other people. If you are leaving, you can leave. Guys, you people think on your own. I'll try to think on your own. Discussing is definitely waste of time. That's a tip for ICPC. In ICPC, you guys should not discuss with your teammates taking away their team, taking away your focus. You have to think deep on your own. That's really needed for ICPC. You guys can leave if you want. I will also end in some time. This has fallen before this. This became 0. That means this becomes 0 later. It can get help from these things. But whatever help it gets, the stays as 0. And then can we see the operation in in a different way somehow? Because it cannot be getting this complex, I think. We see the operation in a different way. What happens? This minus this will become minus ci. I mean, this is most basic one can do. This minus this will become plus ai. Ai plus 1. And then this will become plus 1. Sorry, minus 1. And this length is I plus ai.
See, if this would not have increased plus 1, we would have been easier. If this not have increased plus 1, but then that's increasing. So if I plus 1 fall in before, whatever falls on greater than I will increase. We'll do plus 1. And whatever falls after that on I will do minus 1. That's the problem. It's only less than things affecting this too, right? It's only less than things affecting BI. So can't we move? Can't we move these things above and below as we like? We cannot if there is some other restriction. If there is some other restriction means if I mean if this things has a restriction with the later things, then we cannot move probably. We need some starting point, I think. Last thing falling. Okay, when the last thing falls, it becomes zero, and from that moment, if few things have fallen already, these things will help it. We can try for upper bounds. Is there an upper bound? I think I should sleep, guys. Where are you? Where are their viewers? I cannot answer now, bro. Number of towers fall on a cell is the maximum value you can achieve on that cell. Yeah, that's fine. That's correct, I think. Not fall on the cell, but fall on greater than that cell, I think. Okay, that's a point. But then, will that hold true by number of cells that can fall on this? Let's say maximum number of cells that can fall on this is a number that can change by choosing these things wisely, right? Choosing these side things wisely that can change. And coming from right side is the greediest you can do. Coming from left side is the greediest you can do to increase maximum number of things that fall on this. Now, if you are increasing, if you are waiting for it to fall later, to fall earlier than those, that breaks this, right? See, we want maximum number of things that can fall on this, right? But then for that you have to come greedily from this side. But then again, you're breaking the greediness by going like that. So maximum, that doesn't seem to be holding somehow. We can decrease, but then when you decrease, what happens? You cannot give maximum number of things to the next side thing. Okay, when you decrease, you cannot give maximum number of towers fall on the next side thing. When you decrease this maximum value, because maximum number of things that fall on something is the greediest way you can do, right? So that's not right exactly, because those kind of greedy things we cannot use. We have to come from the we have to get a lower bound, bro. That's for sure. We have to get a lower bound that you cannot do better than this. Like it must break kind of thing. Okay, for I plus 1, there are some things that fall on both of them already. There are some things that fall on till here already. Guys, we can leave. Bro, for this it's 4. So what is that thing that makes it 4? You can do this. You can do this. One comes here. Those two comes here. I think it's just doing these things. Zero, zero. See, how many solves does it have though? It have more solves only. It got diverted. It got diverted in the middle.